Welcome, learners, to this video where we will explore and dive into the libraries in Solidity. Let's embark on this learning journey together. Solidity libraries are special contracts that contain reusable code. They are intended to provide a way to deploy common functionality that can be shared and called by other contracts. So libraries offer several benefits, including reducing gas costs and promoting code reusability. Here are some key points to understand about libraries in Solidity. Reusable code. This means library is like contract that encapsulates a set functions. These functions can be called by other contracts. Actually, this allowing developers to reuse code and avoid duplicating functionality across multiple contracts. The second feature, which is gas cost reduction. This means deploying a library and calling its functions from other contracts can reduce gas costs. When a library is used, the bytecode of its functions is not included in the calling contract. Instead, it references the library bytecode, resulting in smaller contract sizes and lower deployment costs. The third point, it's about stateless. Libraries are assumed to be stateless. This meaning they don't have state variables. They can only define functions, and these functions can only access the data provided to them as function arguments or through external state variables. Okay, the fourth one about view and pure functions. Libraries can contain two types of functions, view and pure functions, okay? View functions are read-only and don't modify the state. Pure functions, on the other hand, don't read or modify the state and only depend on the function arguments. Both view and pure functions can be called directly from outside the library without the need for a contract instance. The we have here, the fifth one is no inheritance. This means libraries cannot inherit from other contracts, and they cannot be inherited by other contracts. So they are standalone units or reusable code and cannot be extended or modified through inheritance. Also, we have here this point about cannot be destroyed. Since libraries are assumed to be stateless and don't have their own state variables, they cannot be destroyed or self-destructed using the self-destruct keyword opcode. Once deployed, a library remains available for use indefinitely. Let's talk about, before this, so by utilizing libraries and Solidity, developers can create modular and reusable code, reducing gas costs and improving code maintainability. So libraries are particularly useful for common utility functions, mathematical calculations, or any functionality that can be separated from the main contract logic. So when defining a library in Solidity, the library keyword is used instead of the contract keyword. Also, libraries are designed to provide a reusable code and have some specific characteristics. We have here no storage variable. This means libraries don't have storage variables. They are stateless and cannot hold any state information. This means that libraries cannot store or modify values between function calls. Also, another characteristic about no fallback or payable functions. Libraries cannot have a fallback function or functions marked as payable, since libraries cannot hold or transfer Ether. There is no need for them to have fallback or payable functions. Also, basic operations. The libraries are typically used for performing basic operations based on input and outputs, okay? They can implement functions that perform calculations or utility operations, but they cannot modify the state of the contract, calling them directly. Also, another characteristic here, support for struct, enums, and constants. So libraries can implement user-defined data types such as struct and enums. These data types can be used within the library's functions. Also, libraries can define and use constant variables, which are stored in the stack of the Ethereum virtual machine, not in the storage, okay? So libraries provide a way to organize and reuse code, especially for utility functions or operations that are not specific to a particular contract's state. They allow developers to separate and encapsulate functionality that can be used across multiple contracts, promoting code modularity and reducing the redundancy. So it's important to note that when using the library's functions are called through a contract using the library, and the contract provides the necessary inputs to the library functions. The library functions don't have direct access to the contract's state or variables. In this example, let's talk about this example. In this example, so the syntax here is library, then we add the library name, and we have here a block of code. In this example, the library is created to demonstrate the procedure to create a library. So we can say here struct constants. This code block defines library named library example. This one, so the name of library is library example. Inside the library, structure name constants. This is the name of the struct, okay? The structure contains 4 unsigned integer variables, by or bi, and we have this variable and the third and the fourth one. So we have here 4 integer variables. The purpose of this library is to provide a convenient way to access and use these constant values within other contracts, okay, by defining the structure inside the library. So the constants can be accessed by other contracts that import or use the library example library. So it's important to note that the code here only defines the structure within the library. In order to utilize the library and its constant, you would need to import the library into another contract and access the constants through that contract. So this example demonstrates the basic syntax of creating a library in Solidity and defining a structure within the library. Look at this. Okay, here we can say a library can be defined on the same contract, as well as it can be imported from outside by using import statements. So here we have a way to deploy a library using 4 keywords. A single file can contain multiple libraries that can be specified using a purely in the import statement separated by a comma. So a library can be accessed within the smart contract by using 4 keywords. Look at this. Here we have library name, then we add 4, then the data type. So this statement can be used to attach library functions to any type. Library name here is the name of the desired library to import, and the data type is the variable type for which we want to access the library. All members of the library can also be used by the wildcard operator, okay, which is like a star, okay. Now here we have an example about the library, and we will apply it in the IDE. In this example, the contract library example, okay, is created to demonstrate how to deploy a library using the for keyword. This code to demonstrate the usage of the library in Solidity. Let's go through it step by step, line by line. We have here Solidity, and we talked about it in the previous video about the license identifier. Okay, let's talk about this block, about library example. This code block defines a library named lib example. Inside the library, there is a function named po, okay, that takes two unsigned integers parameters here, a and b. This function calculates the power of a raised to the power of b using this signs operator, okay, and returns the result along with the address of the library itself. So the purpose of this library here is what? Is to provide the power function, POW, power function, as a reusable calculation method that can be used by other contracts. Now here, defining calling, this code block defines a contract named library example. Okay, the contract utilizes the lib example library using the using keyword. Okay, so we used here using keyword with the for keyword. Okay, this is for keyword followed by the data type uint. Okay, this means that the power function defined in lib example library can be directly called on uint variable, unsigned integer variables. So the contract also has an owner address variable set to address this one, referring to what? To the address of the contract itself. The getPo here function in the contract calls the po function from the library using the num1 and num2 parameters passed to it. Okay, it returns the result of the power calculation along with the address. Okay, along with the address of the library itself. Okay, so this Solidity code demonstrates the usage of the library lib example. We use this library here, provides the power function for calculating the power of unsigned integer. The library example contract, this is the contract, and this is the library. The contract deploys and uses the library, allowing the get powerful function, this function, to directly call the po function on unsigned integer variables. So this is about the deploying library using for function, using for keyword. Actually, also we can deploying library without using keyword. Let's see this code here. We we write here the code about a library and the function power to calculate the power a and b, a to the power b. Then we have here the contract library example, and here we use the keyword to deploy the library, and then we can deploy it. You compile it at the first, then go to the deploy and choose the check the yes. We choose here library example, the contract, then deploy it. Once deployed, we go to the this part. Okay, we go to this part. Then here we should add the numbers, number 1 and number 2. Let's add now 2 and 3. By calling it, we get the result 8. This means 2 to the power 3 means 2 multiply 2 multiply 2. The result will be 8. So this is the result. When we use the same numbers here, 4 and 10, we can right here 4 and 10 call, sorry, let's deploy it again, then go to the and add 4 and 10. I think we got the correct result previously. Yes, this is the result for 2 to the power 10. Okay. Okay, now we will talk about the another topic in the library. Solidity provides several inbuilt libraries and external libraries to simplify development and enhance security. Here we have some libraries, inbuilt libraries. We have here modular network. Solidity offers various modular libraries that can be used for different implementations. These libraries include array UTIL, token, visiting, string UTILs, linked list, wallet, and more. These libraries provide ready-to-use functionality to common tasks such as array manipulation, token management, crowd sale contracts, visiting schedules, string manipulation, linked lists, and wallet management. Okay, so all of these information about modular network. And another library here, inbuilt library, we have this libraries. It's a popular open source framework that provides a collection of secure and audited smart contracts and libraries. It includes actually essential supporting libraries like rules for rule-based access control, miracle proof for miracle tree verification also, and so on. These libraries actually are designed to prevent common security vulnerabilities such as overflow or underflow attacks. Okay, and now we have this library also. It's a library collection created by Ethereum. It includes interesting and useful libraries that can be utilized in a smart contract development. Some example include double linked list for efficient management of double linked lists. We have string UTILs for string manipulation, and more examples about the in this library. These libraries actually provide additional functionality and utility for specific use cases. So using these inbuilt libraries can save development time, improve code quality, and help prevent common security vulnerabilities. It's important to review the documentation and understand how to properly utilize these libraries to ensure their effective and secure integration into your smart contract. This is some brief information or overview of libraries in Solidity. Thank you for watching.